Whoa. Welcome to Honors Geometry. So, I will be your teacher for today. I am Mr. Hess. As you know, have a little discussion about classifications of triangles. So, try to keep you guys on board here and up to speed with everything. All these terms, I've used them before in that last vacation packet. Well, here we are on another vacation, co-location. So you may want to add some marks to these drawings. There's a few things added on here. You'll see, and you probably already know this word. If all the sides are the same, we call that equilateral. If two or more of the sides are the same, we call that isosceles. And if we know none of the sides are the same, we call that scaling. So technically, if you read these definitions, equilateral triangles, a triangle with all congruent sides. This would also apply to squares or pentagon if all the sides are the same. The definition for isosceles is a little bit tricky in that it's at least two congruent sides. So technically, this is an isosceles triangle, which is a little weird to think about, but that's how the definitions work. Scaling, of course, means none of the sides are equal. They're all different side lengths. So you can classify these triangles based on the sides. You could also add another adjective here to describe them based on the angles. But I'm going to separate that here. But certainly there are at least two adjectives that describe that, at least two that describe that, at least two to describe that, based on sides and angles. So if all the angles are equal, we call that equiangular. And that is not a made-up word. I'm not lying to you. Tyler, I'm not lying to you. That's how it's spelled, equiangular. Of course, that means all the angles are equal. We'll talk quite a bit about those. There's a ton of symmetry with those, so those end up being a very, very important shape because they're related to other shapes. If all of the angles are acute, they're all less than 90, we call it an acute triangle. So the word acute can be used to describe one angle. It can also be used to describe the entire triangle if all three of the angles are acute. Now, what could happen is one of those angles gets bigger and bigger and bigger and bigger until it clicks and it's 90. Now, this is a right angle. This green thing is called a right triangle. So again, even though it has two acute angles, the triangle is called a right triangle. And of course, you can't have two right angles because if this were to become 90, this poor little vertex over here would get ripped apart and you'd have two parallel lines instead. So you can only have one right angle in a triangle. And of course, the last one is an obtuse triangle. You can tell just by looking at it where the obtuse angle is. And of course, you can't have more than one obtuse angle on there because probably know some things about angles and triangles. So just so you have some definitions on there. If there are three congruent angles, we call it equiangular for a triangle. This would also apply to squares or rectangles for that matter, because all the angles for a rectangle or square are all 90s, they're all equal. If all three angles are acute, we call it an acute triangle. If it's got a right angle, we can call it a right triangle, and the same thing with obtuse. If there's an obtuse angle on there, you can call it an obtuse triangle. So those are just the basic vocab words. You could also call this triangle acute because all the angles are acute. Looks like you could call that an obtuse triangle as well, and that one is also an obtuse triangle. So the adjectives can both apply to a triangle. They probably should be both applied to a triangle. So you don't have these numbers on your paper. You also don't have these little marks. Don't overlook those. Those little marks tell you some things about congruence. So take a moment and just write down these side lengths for each of these triangles and try to solve for x and y. I'm going to pause this and go to another video. So in a minute or two, you should click on the next one and see if you got x right, you got y right, and then also read those directions. Classify the triangles based on what you see in the drawing or what you've concluded about x and y.